when it comes to the midterm exam, I can delay this discussion until next week. I think since
Yeah, there's no issues with delaying that discussion until next week.
Okay. Anyway, I mean, my promise is my promise. So if we come back next week, and next week is the week number 6, and Monday is Thanksgiving. Make sure that you stay safe. And if we come back on Wednesday, that will be the October 14th. And if we decide to go for the October 22nd, this means you will have about 10 days of notice, which I kept my promise. Remember, I said every assignment or exam, you will have a minimum of 1 week notice. Okay, so let's agree. Let's come back on Wednesday of next week and, just decide on our midterm exam. Okay. Also, you know what? Like, guys, exam from your perspective is just 2 hours. From my perspective, it's a different thing because simply uh, I give you assignments. By now, you have assignment 1, 2, and 3. Okay, so those assignments, I don't want to test you, and while you don't have my feedback on the assignment. I know some instructors, maybe what they do is they give you the model answer, but this is not really the way I like. When I give my model answer to my students, again, they have a false sense of security. They have the best answer for all, and they keep it. It became like let's say, a Bible, and they always look at it, and just to distract them, you should have your answer with my feedback. So again, the midterm exam has to happen after I am able to mark the assignment. And on my plate, oh my God, I don't know how many assignments are sitting on my D2L need to be marked. The good news is I have a long weekend, so I have another 12 hours of work on Monday. Again, no time off, no vacation, no stat day, just work, 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 work. And again, if I'm able to go through the assignments and finish a good amount by Monday, then this will say simply your exam will have to be as soon as possible. If I cannot go through the assignment, then I will have to push your exam a little bit, not much, a little bit. So anyway, guys, you got the idea. Anything you guys want to discuss with me? Anything, any issue you're having right now? One thing I've done, one thing I have done is I sent you, and I'm not sure if you guys are turning notification on the channel. Mahdi, give me a second, please. Okay. I'm not sure if you guys are turning notification on the channel. So whenever I send something on the channel, do you guys are you getting notification, or you're simply making, because by default it is turned off unless you go ahead and change it to turn on the notification. So if you got the notification, I got lots of complaint, whether from this class or other surveying class. They say, Tahir, your videos are all over the place. There are some 3 videos here, 2 videos here, and we have hard time to do that. Which I show some of them how to go on, but I found a better way. I built a channel, and I added those videos to the channel. So now, and only now, probably yesterday, so all your videos from day number 1 until now, they are in one channel. Okay, one channel. So please, if you have difficulty accessing the channel, let me know. But now you don't have to suffer. All the videos are collected in one place, which is a channel for Civil 3D. Sorry, for Civil 355, and for Survey 325, you will find a channel for you. Hopefully, this will make your life a little bit easier. Mahdi, you are about to say something?
Yeah, it's just a question for assignment 3. Is it due, did you say it was due the 14th or the 15th? Because D2L showing 14th.
It is due to whatever on the D2L. You're trying to negotiate and ask politely to change the deadline, I guess.
No, because I got them confused between the survey assignment and the concrete assignment. So I was just wondering.
Last in the surveying, because of you guys asked, so I extended my assignment for 1 day. So now the assignment of the surveying is due to end of Thursday, and the assignment of surveying is end. Sorry, of the concrete is end of Wednesday, I guess. Whatever. Now, before when we hand over the assignment, you have all the rights to ask if it's not clearly mentioned on the assignment. But now, since we have a D2L, D2L has the date. Guys, any other question regarding assignment? One thing I noticed yesterday, 10 students, at least 10, they email me and say, yeah, you know, I was trying to submit my assignment by 11:29, and then I don't know why you keep the assignment until 11:29 and then you press submit. Okay, but again, see what happens. What happened is things didn't go the way we like, and D2L refused to submit the assignment. Deadline is passed, and then you cannot submit it. Okay. And, you know, I get lots of story, you know, I was, you know, doing this and I was doing that, and, you know, all kind of stories. And to be honest, this is just adds to my stress. If you tell me stories and what do you think can I do? I'm not saying that you're lying or anything like that, but you can have to imagine that I'm a teacher. I have to be fair. I cannot give the same mark to the same person who submit the assignment on time and somebody else who submitted late. So I'm going to, for sure, anyone submit after deadline I have to deduct some marks because it's unfair. And really our job, one of the things we do is be fair to you guys, okay? Any other concern? Yeah, please work hard. I know that you guys working so hard, but you know, don't wait until the very last minute, 11:29. Don't do that, okay? Any other concern about the assignment? Okay, so looks like you guys are doing okay. We'll start our class today. Something I want to say before we start, I got some feedback from you guys. So I'm talking to some of you, and some of you saying, you know what, looks like things were kind of easy and now things are getting difficult. And I'm not disagree, I'm in complete agreement. But the way I do it like this, like the curve, my curve is doing like this. It doesn't go like this, okay? So that's why I give you lots of preparation for strength of material, statics, so you're not surprised, okay? Otherwise, if I go right away and jump into the ocean, then you guys are gone, huh? Anyway, so the thing is, guys, if you feel that things are getting difficult, here is what you have to do. You need to study ASAP as soon as possible, okay? When things are getting hard, yes, it's getting hard. I'm not, saying no. However, the way you do it is you study as soon as possible, because as I said, when you study and read the lecture one more time again, this will make a whole difference. Please do that. And again, if you need some help, then I'm here for you. As long as you know you are within the reasonable time, you are a very reasonable person, you will find my support all the time, but please be reasonable, because I'm human like you. I need to sleep, because some people, they text me like by 2 a.m. unacceptable, okay? Anyway, so Jelly, you have something to say?
Yeah, sir. What is reasonable time for you, sir?
I mean, I always go by this rule. Whatever reasonable for you, like if I do the same thing, if I call you one time, you know what's reasonable. I guess we're human like each other. We're equal. We're not like there is no superiority. You are human, need to eat and wash and sleep and all those things. We are the same. And whatever you apply for yourself, whatever you like for yourself, do it for me. Okay?
No, because my schedule is different than your schedule.
No, I understand, but what I'm saying here is that, like, what if I call you by midnight? Is that acceptable? For sure. You'll say,
Of course. Of course not.
Listen,
You are dreaming with your wife there.
let me finish, please. Let me finish, please. Okay? If I do that, I know that what's going to come to your mind will say, Tahir is crazy. Okay? You guys be reasonable, and you guys are adults, huh? You're not young You're not kids, you're adults. I got some people which, to be honest, I was super annoyed and mad. Somebody will text you after midnight asking one question, and after 5 minutes he say, or whatever he or she, I'm not gonna say who, but the student said, you know, never mind. I don't know what is never mind. I don't know what is never mind. I cannot understand it. This is very casual. This is very casual. You text your friend after midnight and you say, okay, let's go for the bar or for the coffee or whatever. But then you say, oh no, I changed my plan. Never mind. That's for your friend, not for your teacher. Please be sure of your question before you ask it. Okay. And some people, you know, it's for them. It's Tahir is very accessible. You know, let's get him instead of us going to the lecture or the PowerPoint or the videos. Okay, you know what? He's gonna give us like a very quick answer. Let's save our time. Don't do that. Go to the video, watch the video, go through the PowerPoint. Then, if you have a question, I will be here in the reasonable time as well. I'm not saying anything odd, to be honest. Like, you know, I'm not crazy. I'm just very reasonable person. Anyway, so let's move on to our class today. And I know that things are getting a little bit difficult. Okay, but again, let's see when I say it one more time, how this, or if it can make it any better. So guys, here, we are in the process of now of understanding the beam behavior. And we said in the last two classes, we said that the beam behaves depending on the amount of reinforcement in your beam. It can be tension failure, where the rebar will yield first before concrete crashes in compression, or both of them, they fail at the same point, concrete and rebar. And then finally, and this is called balanced failure. And then finally, if the concrete crashes first before rebar start to yield, then it's called compression failure. We talked about this one. We looked at some videos, okay? And it's obvious for me, you guys maybe didn't get very well because some of you are looking for some resources on the internet. Some of you guys are going to the YouTube and watching videos from other guys. Fantastic. I don't mind. Do it, please. If you can, do it. Okay. The bottom line for me is you be the best in concrete design. Okay. But we're trying right now, we're trying to put things in action by numbers. So here we go. We have a beam here on the left side with some dimensions, with some rebar, with some concrete strength. And my question is, can you please tell me whether this beam is going to be properly reinforced or overly reinforced or balanced? Okay, so with some given information. Okay, now the way we do it is very simple. We follow kind of a very systematic way. So you can see here on my first step, you have to find your effective depth because this is really what matters. We don't care the H. We don't care the overall thickness of your beam. From the overall thickness of your beam, we should find effective depth. In this example here, I never wasted your time because that's not my focus. I gave you right away the effective depth to be 400. In the assignment, you will have to do a little bit of effort, like in the lecture of properties of material, to find where is the centroid, and then you can find the D. Anyway, so the D here is given to you as 400. Next is you find the area of the steel. Remember, this includes only the main reinforcement. No stirrup hanger, no skin reinforcement. Okay? So we have 7 bars, 25 m. We know by now, and hopefully guys remember that. Every 25 m has a 500 millimeter square of rebar. So which means the total area of the steel in my beam is equal to 3,500 millimeters. Then always, guys, that's what we do. We assume that rebar has yielded at failure. This is just for now, it's an assumption. Remember, assumptions are great. They make our life easy. However, before we make a final conclusion, we have to verify the assumption. We have to come back somehow and make sure that whatever assumed was right. Because if it's wrong, then all the calculation is wrong. So for now, I assume that my rebar has yielded. If the rebar has yielded, it means the stress in the rebar equals the 400. And what's 400? It is the yield strength for this level, for this rebar grade. Then you can find the total force in your rebar. Force is equal to stress multiplied by area. Stress multiplied by area. Are we using 400 for the stress? No, because we already reduced that by 85%, which is phi s. So phi s multiplied by F yield, that's your new reduced stress. You multiply the stress by the area, you get a force. And what is this force? Is the total tension force in your rebar. Then you go back and you say, okay, you know what? Because of the equilibrium, because look at this picture here, the sum of the forces in the x direction should be 0, which means your total compression force in your concrete must equal your total tension in rebar. And from that, you can simply replace the capital C, the total compression, by, again, one more time, by a stress multiplied by area. The stress here is alpha 1 phi c f c dash. This whole term is a stress. It is modified or reduced and then transformed because of the parabolic to rectangle. You take your stress, you multiply by the area exposed to the stress, which is A times B, where B is the width of your beam and A is the depth of your compression block. From that, you can see everything is known except the depth of your compression block, which is A. So mathematically, we can find the A. Remember, when we find the A, doesn't define, or sorry, it somehow defines the location of the neutral axis, because the A and the C, they are related, okay? The A and A are related. How? Very simple. If you want to find where is the neutral axis as defined by the parameter C here. So guys, this C here, it defines where is my neutral axis. Very simple. You divide the A by the beta 1, which is 0.9, you get your C. Guys, once you know the C, little c, as the location of the neutral axis, you can draw your strain diagram. So this guy here, I'm going to box it out. This guy here is what we call it strain diagram. On the top, it is always concrete maximum strain, 0.0035. And then at the bottom here, we don't know. So we are going to assume it's epsilon s. We don't know right now whether this number is equal to the epsilon yield or more or less. We don't know. So we leave it as is. Then we put all the other dimensions from the top to the neutral axis. It will be C, whatever we got C from this equation. And then the rest will be D minus C. We do the similarity of triangles, and then what we got is we got this value for the epsilon s. Once you know the epsilon s, it's a very simple comparison. You compare the epsilon s against a constant number, constant. Don't change on my course. It is going to be always 0.002, which is constant rebar of 400 grade. Maybe if I change my rebar to another grade, then this number will change. But in my course, this number is the same. You can see in this example, the two numbers, the strain in my steel is exactly equal to 0.002. This means my epsilon s is equal to epsilon yield, which means my rebar just yielded, just started to yield. And this is simply tells me that this beam is balanced failure. So when the concrete crashes in compression, 0.0035, this number was 0.002. So both of them, they happen at the same moment. So my beam is balanced section. Guys, so whenever my beam is balanced section, now let's look back to my assumption. Remember, whole calculation is based on an assumption is here. Now the question is my assumption correct or wrong? If you have a balanced section, the stress in the steel is equal to your F yield. Yes or no? I need some noise. Yes or no? When the section is balanced section, it means concrete will crush at the same moment that my rebar will start to yield. Then we can say the stress in the rebar is exactly equal to your F field. Yes or no?
Yes.
Okay, so what does it mean? It means this assumption was true, and it means all my calculations so far is correct. Okay, then I can proceed to estimation of my moment of resistance, or what we call it beam capacity. Beam capacity. Okay, how do we do that? As I said, all you have to do is you have to go and find what is my total tension in my rebar by the numbers, and then what you have to do is also find what is my total compression force in my concrete, and then the moment is nothing more than you take the force multiply by lever arm. So the lever arm here is very simple. It is D, your effective depth, minus your A over 2. Why A over 2? Because it is rectangular block, and assembly we can replace it by a center in the middle. Middle of what? Middle of A. So the lever arm is equal to D minus E over 2. And as I said, please calculate the moment of resistance or the beam capacity from both tension and compression. Because simply if we get two numbers to agree, this is a numerical, a check for my calculations. Are you following so far? I need to hear your voice. Did it make it any better than last class?
Yes, we're following.
Yes. Yes.
Thank you, sir. Okay, so now it's time to go. So far in my class, you have seen two examples by number on two different beams that they have different behavior. The first one, example one, tension failure, ductile, properly reinforced. Beam number two was balanced and it is brittle. And question number three, or example number three, which is on my screen right now. So what we did is we simply, for the same beam in question number two, we added through in like 3 more rebar. You guys see the difference, huh? If I go back one page, you can see this is my my beam here, and same dimensions of 500 H, D400, the width is 400, and it had 725 M. So I kind of copied the same beam here, for example, number three. However, what I did is I simply changed the number of the rebar to from 7 to 10. It means I added more rebar. Let me do a temperature check. Before we do calculations or any number, based on what you see on question number two. This beam, what do you think? Is it going to be overly reinforced or properly reinforced or balanced section? What do you think?
Overly.
Over.
You don't have to think even for a second. We already added a little bit more or more than what made my beam balanced. So if you add very small bar on the previous section, what happened is your beam will start to be overly reinforced because we have so much rebar in the beam. The stress will be less in the rebar, will force the concrete to fail first in compression. Okay, so without any calculation, we know by now that it's going to be compression. However, if I don't have, if I solve it for you, example 1 and 2, probably you don't know. Yes or no? If this is your first example, would you know whether this is balance or tension or compression? I guess no, huh? Just by looking at those number and eyeball it, you cannot know.
You mentioned that from the very beginning, before you made an example.
Yeah, but what I'm saying here is if I never went through example 1 and 2 and I gave you this beam, you cannot tell just by looking at the beam, you cannot tell your beam is overly or properly or balanced section. So anyway, so that's why I'm gonna start with exactly the same procedure as if we don't know, huh? And let's see. So guys, let's see, as I said, same thing. You always have to start this way. You always have to say, let's assume that my rebar has yielded, and this assumption could be wrong or could be right. It is right in case of your beam, your beam is properly reinforced or balanced section. So I did the assumption already. So I said, let's assume that my rebar has yielded, which means mathematically, the stress in the rebar equals the 400 MPa. So what we do next is we go ahead and we find the depth of the compression block, which is A. Nothing more than, I'm going to say my total T my total tension in my rebar is equal to my total compression in my concrete. And you guys know my total tension in my rebar is equal to phi S F field AS, stress multiplied by area, and my total tension, my total compression in my concrete, again one more time, stress by area is equal to alpha 1 phi C FC dash BA, and then you can see my formula. It will make sense for you. So the A is equal to phi S multiplied by F field by S divided by alpha 1 phi C F prime C and then B. Now all you have to do is, since we know all those numbers, we can simply use this equation to figure out what's the A. So based on the calculation you see right now, the A is 326.92. Okay, and I remind you, depth of equivalent rectangular block. Don't be confused. That is not the location of the neutral axe. Next is, we take the same number, we divide it by beta 1, which we agree in this class, always equal to 0.9. So we get a C, which defines the location of my neutral axe. Okay? Now we know the C. So I'm going to go to the next slide. If you know the C, so we do the same thing. We draw one more time our strain diagram, and you can see always on the top, the strain in the concrete is 0.0035. And then you put your C. And you can see here, the two triangles are not really like, they are still similar, but one is so big and the other one is so small, because my neutral axe is really, really attracted to the bottom, okay? So what you have to do, you do similarity of triangles, and what you will get is epsilon S. We are always trying to figure out what is my strain in the rebar before the failure, because simply this will tell me whether it's a compression or tension or balanced. So in this example here, the strain in my rebar was only 0.00035. How this compares to my epsilon yield, which is 0.002, guess what? It is way less, which means if my strain in my rebar is way less than epsilon yield, it means I am before the yield. My beam failed when the rebar is still not yielded, okay? And this is the only time. Now I'm asking you, was my assumption correct? If
No.
I'm saying right now that epsilon S is way less than epsilon yield, which is a constant, huh? I'm asking you, we are before the yield. So that my assumption I made here, this assumption here, is that correct or wrong?
No, it's wrong.
It is wrong, guys. Again, and if you follow, good for you. And if you don't follow, let me show you for one more time, probably the last time, how the stress strain diagram looks like. Huh? So this is my stress strain diagram. From 0, I go with the line, and then here we go from this point, we do the yield. So you can see this is my critical point here. This is where my rebar has yielded. And this dimension, which is from here to there, this dimension here is what we call it epsilon yield. So this number is 0.002, constant, okay? When I estimate my epsilon S, which generally speaking is the strain in the steel wherever the beam failed, we figure out that my epsilon S was less than epsilon yield. It means I'm on this side of this point. It means before the yield. And it means, look at this. So where is my stress? So let me dimension that for you. So guys, from this point to this point here, this is my epsilon S, okay? How about my FS? Obviously, it is this dimension. It is from here vertically to there, and simply this will give you your FS. So this FS and this horizontal is epsilon S. And you can see the FS is less than your 400, because where is my 400? It's from here to there, okay? This is my 400 MBA, okay? So you can see if my epsilon S is less than epsilon yield, it means I'm before the yield, and it means my FS is somewhere less than 400. It means mathematically the assumption I made was wrong. And guys, I put it here in red, and I'll tell you why I put this in red. You can see how much I'm trying to focus. I will bring your attention to this box, because let's read it first and I will tell you what's the problem. So this means the assumption we made that rebar has yielded was not true, and all calculations so far is wrong, and I put it in capital letters, and cannot be used for further calculations. And I know some of you will say, why you do that? I'll share with you guys. Every year for the last 6 years, 2 semesters per year, I explain this, and guess what? Students, they say epsilon S is less than epsilon yield, and then they keep going. They keep going. I don't know why. Okay, so please, hopefully this is clear in the online education. If you found out that the epsilon S is less than epsilon yield, it means it's a compression failure. It means your assumption was wrong. So please don't use any of those numbers, whether the A or the C or anything like that. Never use it in any further calculations. Okay, next is, let's see what can we do if this happens. And I put again, look at the red color and look at the capital letters, solution again. So please, that's what we have to do. I said the beam is overly reinforced. Hopefully everyone agrees. The beam is overly reinforced, and we must recalculate A using quadratic equation. And I know some of you will say, what do you mean quadratic equation? Please be patient, okay? Be patient. Now, if you love math, follow me. If you don't love math, take a nap. Who loves math in this class? Show your hands if you love math. Serious.
Oh my gosh.
Keep going. I want to see that. We have Martin, Garcia, Brody, Baron, Mr. Sunny. Okay, because I'm going to go into a mathematical discussion, and I know some of you love math. And if you love math, follow me. And I personally, believer in a math. Math is the best thing in the world. Okay, so follow me. If you don't like math, please take a nap until I wake you up. Okay. Now, guys, here we go. Now we're saying here, you know, my numbers are wrong. It means my A is unknown. We don't know what is the depth of the equivalent compression block. And also, we don't know what is my stress in the rebar. So you can see here, clearly, I kind of color anything unknown with a color red. It means it's unknown. So you're saying here that A is unknown, and the stress in the rebar is also unknown. So I start here from same thing. We start from T is equal to C, or T sub R equal to C sub R, which is total tension force in my rebar is equal to total compression in my rebar, in my concrete. Guys, this equation, by the way, so you know, it applies no matter what is the failure mode. It applies if I place 1 kilonewton on my beam, or if I put 1,000 kilonewton on my beam. This holds always true, always true. My total tension in my rebar equals to my total tension in my concrete. Okay, sorry, compression in my concrete. Guys, when we do that, this time we can rewrite the equation one more time. There is nothing super science here. I want you to compare between this equation and this equation here. Do you see any difference? There is only one difference. There is only one difference. In this equation here, my Fs was equal to F field equal to 400. How about here? We said that Fs is unknown, and that's why you see A is unknown, and also you see Fs is unknown. So far, we have equation, I'm going to call it equation number 1, and it is function of 2 unknowns, A and then Fs. Are you following so far? So one equation that has 2 unknowns. Can we solve those? If you have only one equation that has 2 unknowns. I think we had the same discussion early in my class about determinate and indeterminate system. We need number of equation to be equal to the number of unknowns. Otherwise, my system, we cannot solve the system of equation. And because we have 2 unknowns, that's 2, and we have one equation so far, it means we can't. So let's try to find other equations. So the other equation, it's here, equation number 2, and this equation, I'm going to box it out. This equation here comes from the similarity of the triangles. Okay, so this equation comes from here. Huh? Look at this figure on the left, which is the strain diagram. So not super science. Those triangles, same as we did 2 times so far or 3 times so far, they are similar, which means 0.0035, which is epsilon C maximum, divided by my C equals to my epsilon S. And remember, I don't know how much, so it's unknown, divided by my D over C, because this base here, this dimension here, let me dimension it for you. This dimension from here to there, this dimension is D minus C, if you agree. Okay, so no super science. I have created here another equation, and let's find out. And I want to mention something here before I continue, guys. Whenever we know the C, we know the A. Whenever we know the A, we know the C, because they are connected. Look at this equation here. Okay, so this equation here, it relates the A with the C. So which means you can think about this equation as an equation in A and epsilon S. Would you agree? If I tell you that this equation is an equation that relates the epsilon S with the C, sorry, with the A, because it relates to the C and C is related to the A. It means in this equation, I can simply replace every C by A over beta 1. So I can cancel this C here and I can put here A over beta 1. Anyway, so far, let me tell you what are the unknowns in this equation. I color them with red to guys see it better. Huh? So we have here my epsilon S strain in my rebar. I don't know how much, and I don't know where is my neutral axe, which is A or C. Now, guys, so far, let me share with you. Now we have 2 equations, but how many unknowns? A and A is the same, so that's A. So that's 1. And then we have Fs and we have epsilon S. So far, I have 2 equations, but I have 3 unknowns. So far, my system of equation is indeterminate, and I cannot solve it. Now, here is my 3rd equation. Here is my 3rd equation, equation number 3, which is what is the relationship between the Fs and epsilon S. Okay, the relationship, this is, we said it early on in my class. You guys, remember when I said the first part of the test will be a line equation before the yield, it's a line equation, and any line equation, it looks like so. Huh? So let me show you. So any line equation will be y equal mx plus c. That's in general, huh? That's a line equation. Since we have no intercept because my line goes to the 0, I can remove the c, and I left with mx. Same here. So this is my m is my modulus of elasticity, as, and this will be my epsilon s, my epsilon, and this will be my stress here. Okay, not my stress or your stress, it's the rebar stress. Okay, so this will be stress, and this will be strain. So here we go, guys. So here we go. We have now we have 3 equations and 3 unknowns. Okay, Tahir, oh my God, are we turning concrete class into mathematics class? Not really, huh? And that's why, because it's not really a mathematics class. So I want you only to understand the beginning only the beginning, and then if we are and we're able to back substitute and do all the magic, and that's what you will get. What you will get is you will get this equation, or this equation. It depends on which you're solving for. If you're solving for A, then you'll get the first form. If you're solving for C, we will get the second form. And I put in red the one in C. Just an agreement. It's up to you. It doesn't matter for me. But let's agree that to use only the red one. Let's solve for C. Okay? And guys, ask you, when you look at this equation, which is function of the C, is it a line or constant or quadratic or third order polynomial or fourth order polynomial? What do you think? What do you think? I need somebody who understands math.
It's quadratic.
Okay. Are you guys in agreement with Jelly? That's quadratic, because quadratic is in the slides, huh? But look at this, please. Look at this, please. You can see here we have the C raised to the power 2, and then we have a C with power 1, and then we have C to the power 0, which is my constant. So this is a math called quadratic form. Okay, and you can see, guys, look at the equation. I know it's kind of very scary, and I know some of you are scared by now, but look how easy we can look at the equation when we change all those parameters with numbers. Okay, guys, please, with your on your own, just repeat with me. Alpha 1 is equal to 0.8. Phi C is equal to 0.65.
0.6.
FC dash is equal to 25 MPa. B is the width of your beam is equal to 400. Where can I get that? It's from the problem. Go up. And then beta 1 is equal to 0.9. Next is my phi S, always equal to 0.85. And then area of steel, we have 10 bars, 25 M. So this number, you multiply 10 times 500, we have 5,000. And ES is the modulus of the elasticity of the rebar, is always equal to 200,000 MPa. And then finally, epsilon C maximum is equal to 0.035. And once you do that, your life becomes super easy. And also what you can do when you look at the D, this number is equal, I guess, to 400, huh? 400. This was your D. Okay. Now, you can totally for now, forget about concrete. And this is a second order polynomial or a quadratic form that we can solve to find the value of the C. Guys, remember, if you are good at math, you will understand this, huh? Generally speaking, in math, any formula that looks like so, like this, this guy here, which is A multiplied by X squared plus B multiplied by X minus C. This is what we call it. What we call this one? We call it quadratic form. And the quadratic form, it's solvable. We can find the roots or the value very, very simple. Before I do that, let me show you what is my A. Is it A here? Somebody who's still awake, huh? I know that some of you by now may be sleepy, but let me ask you, in this formula here, the A is the depth of the equivalent compression block? Yes or no?
No.
Can I get somebody else to tell me yes or no? I need probably 2 or 3. I'm asking you my question. In this equation here, the little a, is it the depth of the equivalent compression block?
No.
Okay, guys, this is what we call it the coefficient, the coefficient of your quadratic form. So all you have to do is simply do all the math, and I did it on your behalf. And probably you guys, I'm gonna do that. If you have a calculator, please do it now. For a second, just do the math and make sure that this number is equal to 1.5731 times 10 to the power minus 3. Please do it now. Please do it now. Everyone in the class, go ahead and check me and make sure that my factor or coefficient of x squared is 1.5731 times 10 to the power negative 3.
Yeah, you're good.
I need everyone, please, in this class. Don't have to tell me. You don't have to tell me, but at least do the calculation on your own. Okay. One more thing to consider here is that what is the coefficient of C? You can see very simple. What's the coefficient of C? It is always 1. What is the coefficient of my which is C here in this equation? Please watch this. It is minus 400. I think this has to change. I think I've done mistakes. So in general, quadratic form is ax squared plus bx plus c. I'm sorry for that. So this sign here, it has to be plus sign. But again, it doesn't change our discussion because I got it here. I said c, which is the constant. It is equal to negative 400, not 400. Look at this number. It is minus d, so that's negative 400. Okay. Now, how can we solve this guy? Okay. So guys, I know that you guys are good at math and maybe you did your math class and that's how we solve it, but I will make your life way easier. Last year when I had the class, I always remind students, you know what? If you have a quadratic form, it gives you two roots. I'm gonna zoom in here. So how you find the roots of a quadratic form? It is minus the coefficient of x. I'm not gonna say A or B, otherwise you'll be confused because this is I'm using here the same A and B, and those are connected to my class, which is C is neutral ax, and then A is the depth of the compression block, and B is the weight of the beam. However, in this equation here, those has no business with concrete. This is mathematics, okay? And that's how we solve and find the roots of a quadratic form, okay? So in this class here, in this problem here, your A is this number, and it is not the depth of the compression block. Your B is equal to 1, your C is equal to minus 400. You put those numbers like so, and what you will get is you will get two roots. Why two roots? Because any quadratic or equation or any polynomial has number of roots equal to the order of the polynomial. So a first order, it has one root. Second order, it has two roots. Third order has three roots, and so on, okay? So here we got two value for the C. Which one you think will be okay and which one is wrong? It's already on my slides. When we say C, which represent a physical value, the depth of the neutral ax, we are not expecting this number to be negative. So you can see I said this one is rejected. So what we do is, here we go, we find the value of the C, and if you know the value of the C, very simple, we know that they are related. Once you know the C, you can find the A by multiplying the C by beta 1, which is 0.9. Are you guys following?
Yes.
Yes.
Okay, let me, before the break, I'll have something to show to you. Tahir, in my assignment or my exam, if my beam is a compression failure, we know if it's a compression failure, it requires more work. It requires more work because simply after you figure out that it is a compression failure, you cannot use the old A and old C. You have to figure them out. And by the way, you don't have to memorize this derivation, huh? You don't have to memorize this derivation. That's only for your for whoever loves math. You can simply use directly this equation here. Okay. Now, do I have to go through this pain and find for me the C? I'll give you some clue, and I guess maybe all you guys know that. Just Google the internet. So you just go here and you say quadratic equation solver or calculator. Guess what? There are so many of them on Google or on the internet. Very simple. What you have to do is, this is the solver. I come here and I say, you know what? Here is my, I want to remember can anybody just help me with the A and B and C?
1.5A.
It's 0.00. Let me do that myself, okay? So if I go back to here, my A is 0.0015731. 0.15731, and then multiply it by x squared, and then plus x, and then minus 400 equal to 0. So you're kind of writing, you're kind of writing your equation, right? And you're supposed to get the answer, and maybe I'm doing a mistake here. I think maybe that's the one. Yeah, exactly. So you can see here, I just write equation and simply solve it for you. You have the root number 1, which is x1, and then you have root number 2, which is 278, which matches my my number here. And then also you get the graph. So this is the graph for the parabola, and you can see there is a negative root, which we don't get it, and there is a positive root, and that root, that's what we get. Okay, are you following, guys? Hello.
Yes.
Okay, with this I wanna break. It's too much information, so we will break. I will see you guys at 2:02. 2:02, please. Thank you.